I'm Steve Mann, and this is Paper Classroom. Welcome to the first of our videos on the wet end processes. Today we're going to start off by talking about dispersing fibres. Now, interestingly, nobody ever calls this dispersing fibres. Everyone calls it pulping. And it's not strictly true, it's not pulping. Pulping is the conversion of a whole plant into individual fibres. But it's a sort of misnomer that everyone accepts. When we throw sheets of pulp or broke or post-consumer waste into one of these devices, we say we're pulping. And because we say we're pulping, we tend to call this device a pulper. In fact, it's not. It is actually a hydropulper. And what it does do, it doesn't pulp fibres, it disperses fibres. So I like to get that out of the way first. What with the process we're actually doing is dispersing fibres, but everybody calls it pulping, but I like to be correct on things like this. Okay, so dispersing fibres. First of all, I suppose we ought to talk about what type of fibres do we disperse. Of course, we disperse virgin fibre. So we buy, do I have any around? Yeah. We buy sheets of pulp like this, and we throw it in a pulper, and we're dispersing those fibres. So it's a pulp mill that has made these. A pulp mill has brought in some trees, converted it into pulp, and then rather than go on to make paper out of it, they've turned it into these thick sheets and baled them and sold them to us. So virgin fibre is the first type of fibre that we might pulp. Then of course another type of fibre you want to do is broke. And of course there's two types of broke, isn't there? There's wet broke and dry broke. Wet broke comes from anywhere up to the end of the press section, and dry broke comes, from the middle of the dry section, the reel up, slitters, rejected materials. So broke is another type of fibre. Then you've got the lowest of the low, the worst of everything, mixed waste, low quality post-consumer waste that could contain anything. It might be cardboard boxes, it might be photocopy paper, it might be milk cartons, it might even be plastic bottles and glass bottles, wire, bits of wood and string. It's the worst of the worst, so you need a type of pulper that can deal with all that. And then you've got a type of pulper that would deal with very carefully selected post-consumer waste, one where you've kept the worst of the worst away. Obviously you pay a lot more for that, but there is a place for it, and you would need a pulper that will deal with that type of waste. So those are the things that we're going to be talking about. We'll start off with this. This is a high consistency pulper. High consistency pulpers can operate anywhere from 15 to up to 40%. I've never seen one working at 40%. I've seen one working at 35%. And again, I always tell my students it's easy to recognise a high consistency pulper because it has a high profile rotor. You'll see later a low consistency profile, a low consistency pulper has a low profile rotor. So first thing to do, observation, high profile rotor, high consistency pulper. And both high and low consistency pulpers have got advantages and disadvantages. And almost exclusively, the advantages of one are the disadvantages of the other, and the advantages of the other are the disadvantages of the one. And here's some examples. So high consistency pulpers are fairly energy efficient. If you imagine that you've got 30% consistency in there. That means 30 kilos of fibre to 70 kilos of water. So that energy is going into 30 kilos of fibre, helping to pull them apart. High consistency pulpers don't rotate anywhere near as fast as low consistency pulpers, but they do have a lot of torque, a lot of power. So because they don't rotate as fast, they do not damage the fibres anywhere near as much. So because they don't damage the fibres, you'll end up with an average longer fibre length than with a low consistency pulper. You won't break the ends off the fibres as much, so you'll have less anionic trash. And one of the novel features of this, because the consistency is so high, it makes the fibres rub against each other, and in doing so they abrade each other's surface, and so you're achieving external fibre fibrillation before you get anywhere near a refiner. So that's really good. The two disadvantages of high consistency pulping: one is it's batch processing, and the whole world wants to do everything as continuous processing. So batch processing, you throw in an amount of water, you throw in an amount of fibre, it whizzes around for a set time, and then you empty it, and then you start all over again. Nobody wants that anymore. Everyone wants continuous feed and continuous extraction. And the other disadvantage is because it's so relatively gentle compared to a low consistency pulper, it's not really suitable for wet strength papers. If you put some paper in that's got a lot of wet strength, it will come out unscathed. You will not have shredded it, you will not have dispersed all the fibres, it will still be a lump of wet strength paper. Okay, so that takes care of high consistency pulping. Let's move on now to low consistency pulping. Oh, high consistency pulping, by the way, is the one that's most suitable for virgin fibre, ideally. Now, ideally, you shouldn't use anything other than high consistency pulpers for virgin fibre. Low consistency pulpers are really suitable for broke and for mixed waste. The advantage of low consistency pulping is you can use it in continuous process mode, so you constantly feed in water, constantly feed in fibre, and constantly draw out your dispersed fibres. The other advantage is because it is so aggressive, because that rotor revolves so quickly, it will break down wet strength papers into individual fibres, but at the same time it will cause them a lot of damage. So the disadvantage of low consistency pulpers are it does damage fibres. If you take a fibre, like this, you throw it in there, then before it gets a chance to absorb water and to swell, it snaps. So you've now got two short fibres. So you're constantly reducing the average fibre length. And a little mantra I've been saying throughout these courses is the longer the fibre, the more the crossovers, the stronger the sheet. Therefore, damage to fibres, the shorter the fibres, the fewer the crossovers, the weaker the sheet. Because it snaps fibres in half and it snaps the ends off, it will also create quite a bit of anionic trash, which we don't want. And finally, it's not very energy efficient. This might only be 4 to 6%, so if it's 5%, that means for every 5 grams of fibre, you've got 95 grams of water. So all the energy is going into that 95% of the water. Little of it is going into the fibres themselves. So it's not a particularly energy efficient process. Okay, so that takes care of low consistency pulpers. Let's just have a look at the next one now, which is the Ragger Junker. Now the Ragger Junker is just a low consistency pulper with some bits added on. So this is the sort of device that we'd use for the lowest quality waste, for the mixed waste, where you've got magazines in plastic envelopes, you've got cardboard boxes, you've got babies' nappies, you've got plastic cups and straws, bits of string. So this bit here is what you've just been observing, really, a low consistency pulper. But here we have this device that we call a ragger. And in the old days, it used to be a big metal chain that was thrown in. Today, we tend to use a piece of rope. So we've got our low consistency pulper here. The stock's whizzing around. We throw in this long piece of rope, not too long, just short enough so it doesn't get caught under the rotor. And the interesting thing here is when we throw our bales of pulp into this device, although we cut the wires that are holding the pulp together, we do not remove them. We leave the wires to go in with the pulp. And what happens then, of course, is the wires get spun, they entangle on this rope, and you've then got a metal rope. This rope grows in length. So you've got to then pull it out so that the end of it doesn't get trapped under here. And the more bales you put in, the more will tangle around here, the more you will pull this out, and so on. And what that does is, if you've any flexible packaging there, like say magazines wrapped in plastic covers, then when the magazine hits that rotor, the plastic cover gets torn open, the magazine gets pulled out and shredded, and if you're not careful, that cover will also get shredded, and then you've got to deal with tiny bits of polypropylene or polyethylene, plasticky things all the way through your system. But by having those wires there that entangle things, it will take that wrapper out of the system before it gets a chance to be shredded. So that's the advantage. So with the worst quality waste, at every opportunity, you take the chance to improve the quality by removing some contamination. And here, even at this first stage, even when you're only just dispersing the fibres, you're using the opportunity to remove contamination. So, sort of biggish pieces of flexible packaging will get caught in those wires and go out. Underneath the rotor, the base is perforated. So as the fibres do get dispersed, they will be sucked out through there and carry on to the next stage. Amongst the contamination, other than plastic, you might find coins, nuts, bolts, lumps of metal, glass. Glass will be shredded, of course, but heavy pieces of metal will fall down here into this device that we call a junker. And typically, either once a day or once a shift, someone will open a little door in here and pull out all that metal and close it and carry on. So we can remove small metal objects this way, but floating round here will be some of that flexible packaging that we were not able to take out the system, that did get shredded. There might be CDs that have got shredded, plastic pens. So those tiny bits of floaty plastic will be floating around in here. So we will bring them up, put them through a little drum screen. Any useful fibre in the stock will pass through the perforation of the drum stream back into here, and then hopefully under the rotor and out through there. All these small solid objects that are too light to settle down in here, then they'll be caught in this drum screen. They'll climb up the wall and then drop down and be caught in a skip or something like that. So that really takes care of hopefully the ragger junker. And the final piece of kit that we might use for dispersing fibres is the drum pulper. Now this is the most gentle of all the pulpers. Because it's so gentle, you are going to retain all your fibre length. But because it's so gentle, you've got to be careful what you put in it. If you've got, for example, if you have a piece of blue hand towel, blue tissue full of wet strength, if that dropped in at this end, it would fall out of this end intact. So you don't want to be buying something that you're then going to have to pay for someone to take it away. So this bit here is the key: selected waste essential. This is the sort of process that's used in the newsprint industry. They bring in old newspapers and turn them into new newspapers. So they're very, very selective in the fibre that they bring in. It's going to be newspapers without supplements, magazines without gifts attached to the front of them. So newspapers and magazines will come in here, they'll go through the first part of the drum, and I'll talk about that a little later in a moment. Go through the second part of the drum, useful fibre goes through here, any material that we don't want that didn't break down will fall out at the end and again be skipped away. So that's an overview of the drum pulper. We're just looking in a little more detail at the beginning, the first half. So as you see, the drum is circulating round in this direction. The drum will contain these baffles. Those baffles will pick up the pulp and then just drop it. That's all it does. So if this was a piece of paper, if it was wet, it will pick it up and drop it. And that's the only forces, the force of gravity. That's all that operates. We have, of course, high pressure showers, either water showers or alkaline showers, such as either sodium hydroxide or sodium silicate. And the idea is that picking these up and dropping them gently will not damage any fibres, but it will help them all to fall apart, particularly with the addition of the alkali. And the first half of that drum pulper is like that. It's on an angle of about no more than 2 or 3 degrees, rotates at maybe 4 or 5 up to 10 revolutions per minute, and the material works its way down the slope. In the second half of the drum pulper, as you can see here, the screen is perforated. Here we have a lot more showers than we had in the first half, but they're all water showers. We have some small baffles again, so everything that's already been reduced to a fibre will go straight through the perforation. Everything that's not been reduced to a fibre will get picked up by these baffles and dropped, and if it is a fibrous material, there's a good chance it'll get broken up and passed on at that point. Anything that shouldn't have been there, pieces of wood, bits of string, CDs, cosmetics, that will fall out of the end, and then that will have to be, some will have to pay to dispose of that. So that's the thing we're trying to avoid. So hopefully you've seen the full range of material for dispersing fibres. Virgin fibre with the high consistency pulper, broke and recycled fibre with the low consistency pulper. The worst of the worst when you go on to make things like corrugated cardboard with mixed waste, the Ragga Junker system, and then this for reprocessing newsprint, the drum pulper. So I hope you found that interesting. It's all I need to talk about that. In my next tutorial, we'll talk about the next stage, what I called secondary dispersion, which is what we do to tidy up at the end of either of those 4 particular methodologies. Well, thank you for watching anyway. I hope you enjoyed it. I hope you found it informative. Please feel free to ask questions or make comments, and I look forward to seeing you in another Paper Classroom video.